We have a problem here that states a 75 milliliter solution of HCl, which is hydrochloric acid, with an unknown concentration is titrated to the equivalence point with a 27.3 milliliters of 0.157 molarity calcium hydroxide. What was the concentration of HCl in the original solution? We first need to go back and determine what parts of the problem are important to solving it. From the problem, we learned that we need to find the initial concentration of the HCl solution. Sometimes this is easier to understand when you draw a picture of what is going on. So as you see here, we have a 75 milliliter solution of hydrochloric acid, and to that 27.3 milliliters of 0.157 molarity calcium hydroxide are added to it. This is a dilution problem, so we will use the initial concentration times initial volume equals the final concentration times the final volume to solve it. We are trying to find the initial concentration, so we need to solve for Mi. We do that by rearranging the equation, as you see here, and multiplying it by the stoichiometry from the balanced reaction. In order to do that, we need to write the balanced reaction for the problem. You first write down your two reactants that you get from the problem, and you need to determine what products will be made from it. You do that by joining the positive element to the negative element, or ion, to create water, and vice versa, to create calcium chloride. After you balance the reaction, it's best to check your work to make sure it is done correctly. You do this by counting the number of each element. We have 2 hydrogens here, and 4 on this side, so that's right. 1 calcium, that's correct. 2 oxygens, that's correct. And 2 chlorines on each side, which is correct. So now we know for sure that our reaction was balanced correctly. We now want to go back to the rearranged equation that we made and plug in the numbers. We do that by plugging them in to where 0.0273 liters of calcium hydroxide times 0.157 concentration or molarity of calcium hydroxide divided by the volume of HCl, which is 0.075 liters. It is important to always remember to convert from milliliters to liters, or the answer you get will be wrong. After you plug those numbers in, you want to multiply by the stoichiometry from the balanced reaction. From the balanced reaction, we get that there are 2 moles of HCl for every 1 mole of CaOH. We know that 2 moles of HCl needs to be on top because we are trying to solve for the concentration of HCl. After that, you do the math and you get that the concentration of HCl, or Mi, M initial, is 0.114 molarity. And that is your answer to this problem. Now to recap what we did. It's always important to highlight the important parts of the problem and figure out exactly what you were being asked. If you don't know what you were being asked, there's no way to solve it correctly. You then want to write the proper equation and make sure it is balanced. If it's not balanced, once again, you cannot get the correct answer. After that, and you're sure everything you've done is correct up until this point, by checking your work, you plug in the numbers and do the math. Some common mistakes that are often made when doing a problem like this is that the equation is not balanced correctly, but you can make sure it's balanced correctly by counting the number of elements on each side. Another thing that is very important to do is to always convert from milliliters to liters. And then you want to make sure you multiply by the correct stoichiometry, which goes back to making sure your reaction is balanced correctly. You also want to make sure that you have the correct moles on top and bottom of the equation. If you switch them up by accident, that would also give you the wrong answer. For example, if we would have put 2 moles of HCl on the bottom and 1 mole of COH on the top, that would have been wrong. So that is very important to make sure you put them in the correct place.